This is R.D. Sharma solution class 12 chapter 13 derivatives as a rate measure. Exercise is 13.2. The side of a square sheet is increasing. Now square means the shape where all the sides or edges are equal. So it is increasing at the rate of 4 cm per minute. So this is a rate. Rate is always, when it is not given, always with respect to time. The denominator will always be time. At what rate is the area increasing when the side is 8 cm long? So there is a rate of increasing, there is a rate of decreasing. That rate, that is the elongation or increasingness with respect to time, we have to find out. So formula we already have. The question is also saying area increasing, that we need to find out. Area is side square. Here we are taking side as x because we always take x when we are dealing with derivative. So area increasing, the side of the square sheet is increasing. So what is the side? We have taken x as the side. Okay. So this side dx by dt. If x is the side, dx by dt is given as 4 cm per minute, and that also this 4 cm per minute infer that you have to take dx by dt. Alright, so 4 cm per minute it is, and area is still x square, but we haven't found out the rate of increasing of area. That can only be computed when we take dA by dt. So dA by dt is a differentiation of x square, which is 2x, but we are differentiating with respect to t, not x. So we have to introduce, or we have to differentiate x and write it as dx by dt 2, and then we have this dx by dt already being given in the question, 4 cm per minute. X is what? When the side is 8 cm long, so we put 8 in the place of x. 2 into 8 into 4 is 64, and centimeter, it's centimeter, then minute, so centimeter square by minute. The minute is also, the unit are also very important. An edge of a variable cube is increasing at a rate of 3 cm per second. So 3 cm per second, edge of a variable cube. So there is a cube, but it is varying. It may be increasing, it may be decreasing. But cube is a shape, is a three-dimensional shape where all the side, all the edges are similar, equal. How fast is the volume of the cube increasing when the edge is 10 cm long? What is the volume of the cube? It's x cube here, because we are taking x as the side or the edge of the cube. Now edge of the variable cube is increasing, so d, if you take x as the edge, so dx by dt is given in the question, which is 3 cm per second. This is already given. So dx by dt, you can write it separately somewhere, since you can write, as I've given you the reference also of the solution. The dx by dt is 3 cm per second. How fast is the volume of the cube increasing? So volume increasing or decreasing means dv by dt we have to find out. But we have to find out dv by dt, but on the right we have only x. So we have to differentiate x cubed, which is 3x square. And differentiation of x also we have to do dx by dt, because we are differentiating with respect to t, not x. So what is the dx by dt? Already given in the question, 3 cm per second. And what about this side? It is saying edge is 10 cm long. When the edge is 10 cm long, so you have to put 10 square here. So when you do 10 square, it will be 100. 3 into 3 is 9. It is going to be 900 centimeter cube. Why? Because centimeter square into centimeter is going to give you centimeter cube, and centimeter cube, since it is already having a second in the denominator, it is going to be 900 centimeter cube per second. Alright, so this is dv by dt we have found out. The side of a square is increasing at the rate of 0.2 centimeter per second, 0.2 centimeters per second. Find the rate of increase of the perimeter of a square. Square, all sides equal. Area, we already seen. Perimeter, 4a, 4x. If you take the side of a square as x, then 4a or 4x, because we always take x, so 4a is the perimeter. So you just write perimeter as 4x, and since the rate of increase of the perimeter have to be found out, dp by dt we have to find out, and since this side of the square is increasing at the rate of 0.2 centimeter per second, dx by dt is already given in the question, which is 0.2 centimeter per second. So dp by dt we have to find out. On the right there is no t, so you have to introduce dx by dt. At that place you are going to replace 0.02. So dp by dt, differentiation of 4x is 4, x differentiation is 1 only, and then dx by dt also to be introduced. Dx by dt is given as 0.2. So it will be 4 into 0.2 centimeter per second, that is going to be 0.8 centimeter per second. This is your dp by dt, which is the rate of increase of perimeter of the square. If you make the diagram, it will be very, lucrative for the examiner. He will give or she will give good marks. What is the rate of increase of its circumference? The radius of the circle is increasing at the rate of 0.7 centimeter per second. Now circumference is 2 pi r. Just write C as 2 pi r. Rate of increase, that is dc by dt, we have to find out. dc by dt, whenever there is a rate, always remember there will be a time in the denominator when in the differential. Radius of the circle is increasing at the rate of 0.7 centimeter per second. That is dr by dt is already given as 0.7 centimeter per second. Now dc by dt we have to differentiate. Means C we have to differentiate. dc by dt is going to be 2 pi dr by dt. There is no see, this is r and you are differentiating with respect to t, not anything. There is no x, there is no r. dr by dt, but dr by dt is already given in the question, which is 0.7. just provide it here, 2 into pi into 0.7. You can just write it as 1.4 pi centimeter per second, but pi you can write as 22 by 7 also. When you write 22 by 7, because this 0.7 is specially given in order to cancel the thing so that the result will come handy or easier. So you can write 22 by 7, or you can even finish up your solution with 1.4 pi. It's up to you. So 2 into 22 by 7 into 7 by 10. 0.7 is 7 by 10. 7 gets cancelled. This is 44 by 10, which is 4.4. 4.4 centimeter second is also the answer. The radius of a spherical soap bubble is increasing at the rate of 0.2 centimeter per second. Radius, sphere, rate of increase of the surface area. So we have to find out we have to know basically the surface area of the sphere, and the radius is given. At what point we have to find out? So we know that the surface area of the sphere is 4 pi r square. It's already given that the radius of the spherical soap bubble is increasing at the rate of 0.2 centimeter per second. So dr by dt is already given as 0.2 centimeter per second. So we have to find out the rate of increase of its surface area, ds by dt we have to compute, which is 4 pi. This r square is going to be 2r. There is no this t here, so we have to introduce dr by dt here. dr by dt is already given as 0.2 centimeter per second. So this 4 into pi into 2, and at what radius? 7 centimeter given in the question. Just write it here. 4 pi into 2 into 7 into, there is 2 missing. Just remember 2 I have missed, into 0.2. When you compute, it is going to be 11.2 pi centimeter per second, but you can also compute it using pi as 22 by 7, because 22 by 7, 7 and 7 will get cancelled. A balloon which always remains spherical is being inflated by pumping a 900 cubic centimeters of a gas per second. Find the rate at which the radius of the balloon is increasing when the radius is 15 centimeter. Sphere, it's already given. There's a rate also given. Okay, 900. So this is the rate of how the balloon is getting inflated. Means the air is getting pumped up and the size is increasing. So this is volume you're talking about. Centimeter cube, that means volume. Centimeter square, that means some area. So the radius is given. At what point we have to find out? It is 15 centimeter. We already know the volume of the sphere, which is 4 by 3 pi r cube. We have already seen this. You need to know the volume, area, etc. dv by dt we are going to find out. 4 by 3 pi, this is going to be 3 r square. And for r, because we are differentiating with respect to t, it is going to be dr by dt. dr by dt is already given. Oh, not, because rate of at which the radius of the balloon is to be found out. So dr by dt is to be computed here. dv by dt is already given in the question, which is 900 centimeter cube per second. Alright, dv by dt is 900 centimeter cube per second, and 4 by 3 pi 3 into r square. R square is also given, means r is given 15. So 900 is equal to 4 by 3 into 3 into 15 into 15, which is going to be 225. And dr by dt. dr by dt, in order to compute this, just take dr by dt on one side. All other things you just push it on the other side. So 900, 3 gets cancelled, 4 pi will come in the denominator, 15 square will come on also in the denominator. 15 square is 225, 225 into 4 is, I'll just compute it, okay? That is going to be 900 anyways. So we have 15 into 15, which is 5, 5, 25 by 75, 1, 5, 5, this is 12, 1, 225. This is 225. Into 4, you already know 225 is 450, 450 into 2 is 900. We already know, just for the sake of completion, because you need to show the examiner that I know this, I have computed this. On the right hand side, you can just find a small space to do all the computation. So this is the answer, okay? Please remember it is centimeter per second because we are finding the dr by dt. The radius of an air bubble is increasing at the rate of 0.5 centimeter per second. dr by dt is provided to you. How did I get the idea? Because it is centimeter per second. From the unit I got the idea, it is talking about only dr by dt. At what rate is the volume of the bubble increasing when the radius is 1 centimeter? Volume is what? We're talking about a bubble, which is a sphere. Volume is 4 by 3 pi r cube dv by dt, which is going to be 4 by 3 pi 3. This is 3r square, and then dr by dt. So what we have to find out? This is dv by dt we have to find out. Dr by dt is already given, which is 0.5 centimeter per second. So 4 by 3 into pi. You can always replace this pi by 22 by 7. But normally we generally write in the form of, or with having a pi here. 3 gets cancelled. 4 pi, this is 0.5, which is going to be 2 pi centimeter cube per second, which is dv by dt, the rate of volume of bubble increasing when the radius is 1 centimeter. So dv by dt is your final answer. A man 2 meters high walks at a uniform speed of 5 km an hour away from a lamppost 6 meters high. Find the rate at which the length of his shadow increases. Now this question, I'm going to explain it in a very detailed manner, because many questions we are going to encounter in the same way. So let us make a diagram. Let me make you understand what we are trying to do here. So here is a person. The person or a man is 2 meter high. His height is 2 meters from the ground, and he walks away from the lamppost, which is 6 meters high. So just make the size should be thrice of the size of the man, because he is 2 meters high, the lamppost is 6 meters high, and he is going away on the right in this direction. It is going right on the right. Find the rate at which the length of his shadow increases. So we are going to use the similar triangle, and then because from the lamppost there will be a shadow. This is the height, just 2 meter. This is the height, which is 6 meter. We don't know this one, so it is x, and this we are going to use because he's going on to the right. He's moving away. We are going to use dx by dt for that. Y is the size or the length of the shadow. Similar triangle, I don't need to tell you because you already know it very well. So this is A, this is B, this is C, this is D, this is E. So we are talking about two triangles, which is the bigger triangle ABE and the second triangle, which is CDE. So just take this AB divided by CD is equal to AE divided by CE. So we are talking about two triangles, ABE and CDE, and these two triangles are similar. So the side corresponding have an equal ratio. So AB by CD is equal to AE by CE or EC. Now just have to replace the things which are given in this question. AB is 6, CD is 2, AE from here it is x plus y, CE is a y. Now this is 3, 3y is going to be x plus y, y comes on one side, it is going to be 2y equals x, or you can say x equals to 2y. We are interested in dy by dt. Remember, rate at which the shadow, length of his shadow increases. So we are interested in dy by dt. Differentiate both the sides. One of the thing is already given because the rate at which the man is moving away from the lamppost is already given as 5 km an hour. Alright. So dx by dt, because the distance of a man from the lamp we have taken as x. So we are going to write 5 for dx by dt, and dy by dt is what to be computed, which is the rate at which the length of his shadow increases or decreases. So dy by dt, just put it here, dx by dt 5, dy by dt is 5 by 2, which is 2.5 km an hour. Please remember, in these type of questions, the units are very important. If you don't write unit, then the marks will be deducted. It will be 2.5 km an hour. A stone is dropped into a quiet lake and waves move in circles at a speed of 4 cm per second. At the instance when the radius of the circular wave is 10 cm, how fast is the enclosed area increasing? This is a circle, or this is the formation of the waves. So it's a quiet lake. When you put some stone or make some movement, these are concentric circles. Waves always are found in concentric circles in this case. So the dr by dt, always in the radial direction, the waves moves away from the center. So dr by dt is already given as 4 cm per second. The radius, at what value we have to find out, the answer is 10 cm. How fast is the enclosed area increasing? Area is already known to us, which is pi r square. Area is pi r square. So let us differentiate this. For the reference, I am providing you the answer also. dA by dt we are interested in, which is going to be 2 pi r dr by dt, because pi, differentiation of r square is 2r. So 2 pi r dr by dt is 10. See, certain things are given here. dA by dt we have to find out. dr by dt is 10 cm per second, and at what radius? 4 cm radius we have to find. So in place of r, r, you're going to replace the proper value for dr by dt as 10. So it is going to be 80 pi centimeter square per second. This is your answer. A man 160 centimeter tall walks away from a source of light situated at the top of pole 6 meter high. So this is a pole which is 6 meter high, and there is a person who is 160 centimeter tall. So 6 meter is pole, 160 centimeter. So we have to convert it into the meter divided by 100. So we'll get 1.6 meter. Now he is walking away from the source of light. So on the right he is moving, and from the pole what will be the shadow? This is how the shadow will be formed on the ground. So let us call it as y. The rate at which he is moving is 1.1 meter per second. So we are going to take dx by dt as 1.1 meter per second. So how fast is the length of his shadow increasing when he is 1 meter away from the pole? That is dy by dt has to be computed. So this question we have already seen in the previous discussion. So we'll use the similar triangle properties. So this is A, this is B, this is C, and this is D, this is E. Now this is a bigger triangle ABE, and the other triangle is CDE. So the corresponding side will have the ratio. That is equal ratio, you can call it. So we can just say 6 by 1.6 and divided by x by x plus y by y. So most of the things I already told you what we are going to take, and this is 1 meter away, so I don't think we are going to use that thing 1 meter away from the pole, because we need to know the speed or the rate at which the shadow is moving. Dx by dt is the movement of the guy, dy by dt is the movement of the shadow. So dx by dt is already given as 1.1 meter per second. So let us resolve this. We have 6y equals, I'm cross multiplying it, 1.6 plus 1.6 into y, and just take y stuff on one side, x stuff on one side. So 6y minus 1.6y is 4.4y equals to 1.6 into x. So we have y here, x here. So this y will be 1.6 divided by 4.4x. This dot or decimal you can cancel. And then let us differentiate. Dy by dt is equal to 16 by 44 dx by dt. Because we are differentiating with respect to t, so we ought to have a t in the denominator. And what is this? dx by dt is already 1.1, so I'm eliminating dx by dt and replacing it by 1.1. 16 divided by 44, so you can just cancel this out. You'll get 0.4 meter per second, which is your dy by dt. This 1 meter away will not be used here. A man 180 centimeter tall walks at a rate of 2 meter per second away from the source of light that is 9 meter above the ground. How fast is the length of his shadow increasing when he is 3 meter away from the base of light? So similar questions we have been doing. So I'm just writing it. 9 meter is the height of the pole or the source of light, you can say. 180 centimeter divided by 100, so that you get the height of the man in meter, which is going to be 1.8 meter. So similar triangle again, 9 by 18 is equal to x plus y divided by y. So there is a relationship. Let's cross multiply and try to find out the relationship between x and y. So this is going to be 9y equals 1.8x plus 1.8y. The 9y minus 1.8y is 7.2. This is what we are deducting, right? So it is going to be 7.2y is equal to 1.8x. And then we have a relationship because 18 4s are 72. If you multiply 18 with 4, you get 72. So 7.2y is equal to 1.8x. X will be equal to 7.2 divided by 1.8. As I told you, it is going to be 4, so it is going to be 4y. Let us differentiate. Dx by dt is equal to 4 dy by dt. Now this is 2 meter per second. What is this? It is he is walking away. So dx by dt is given, which is 2 in this case. 2 is equal to 4 into dy by dt. We are interested in dy by dt. And the length is increasing, or the shadow is dy by dt. So dy by dt is 2 by 4, which is going to be 1 by 2, which is 0.5 meter per second. A ladder 13 meter long leans against a wall. Let me show you the diagram first. So there is a ladder 13 meter long leans against a wall. This is a wall. So this is a ladder. Now the foot of the ladder is pulled along the ground away from the wall. So it's being pulled away. So the right side, it will be lower and the bottom will be higher in this case. So let us call this is y and this is x, and we are going to use the Pythagoras theorem to do that, and after that we are going to provide some trigonometric relationship here. So this dx by dt is nothing but 1.5 meter per second, because this is the rate. This is the rate of the ladder being pulled away. 13 meter is the length of the ladder, so let us write it. So this angle we are interested in, d theta by dt. How fast is the angle theta between the ladder and the ground is changing? D theta by dt we are interested. So d theta by dt. Okay, so you have x, this is y. Let us use the Pythagoras theorem. X square plus y square is equal to 13 square. And see, x and y has a relationship. See, tan theta is y by x. So y is equal to x tan theta, you can write. Tan theta is y by x. So y is equal to x tan theta. So I'm just replacing it by x tan theta, y is x tan theta. So it will be x square tan square theta. And 13 square is 169. X square you can take common, 1 plus tan square theta, which is going to be sec square theta anyways. 169. So x square into sec square theta is equal to 169. Now you can differentiate it. Either you can use p and q as x square and sec square theta, use the product rule, or you can bring down x square on the right hand side in the denominator, call it as x to the power minus 2 when it goes up. So here we have, I'm differentiating sec square theta. So it will be 2 sec theta, then sec theta will be sec theta tan theta. Here on the right we have 169. X to the power minus 2 will be minus 2. X to the power minus 2 minus 1, that is minus 3. And this is minus 2, x minus 3, I'm taking it in the denominator. Okay, we are differentiating with respect to t, not with theta, not with x. So you ought to have certain things here. You have to introduce d theta by dt here. And here also, we are doing it with respect to t, remember. It will be dx by dt. So d theta by dt we are interested in finding out. So this is d theta by dt. What else goes? This 2 you can cancel. 169 here divided by sec square theta. Sec theta is sec square theta. And then we have tan theta. Negative it will be x cube in the denominator. And dx by d theta. Now this is 13. The 40 is 12 from the wall. So x is 12 here. You can replace x cube by 12 cube. And dx by dt is also known to us. It is 1.5. But what about these? Second hand. So Pandit Badri Prasad Har Har Bol. This is what we follow. Sin theta, cos theta, tan theta. So cos theta will be base upon hypotenuse. What is base here? This is 12 by 13. What is sec theta? It will be 13 by 12. So it is minus 169 divided by 13 by 12 whole square. Tan theta is perpendicular by base. You already know how to do that. And dx by dt is what? As I told you in the earlier discussion, it is 1.5. So write everything what you know. And then we have tan theta. Tan theta is what? Perpendicular by base, which is going to be this y by 12. Y we don't know. So y square will be 13 square minus 12 square under root. Again, Pythagoras theorem we are going to use. 13 square is going to be 13 square plus 12 square. No, this is not. This 13 square will be equal to p square plus 12 square. So p square will be equal to 13 square minus 12 square. 13 square is 169. And this 12 square is 144. 169 minus 144 is 25. Under root 25 is 5. Okay. All the values are known to us now. There is only computation, and remember that computation is going to come in radian per second. X cube is 12 cube here. So minus 169. All these the values are known to us. I already told you also. And then finally, what is the result? The computation result is going to be minus 0.3 radian per second. Okay, all this computation which I am suggesting is going to give you 0.3 radian per second. So angle always we take in radian, please remember. Okay, it is not being told, it will always be in radian. Otherwise it will be in degrees. Alright, this is... I hope you got the idea. So many of the questions of the same sort we have solved, and there will be moving x, there will be moving y. Most of the time dx by dt or dy by dt we have to form. A particle moves along the curve y is equal to x square plus 2x. This is a curve. At what points on the curve are the x and y coordinates of the particle changing at the same rate? So dx by dt is dy by dt is equal to dy by dt, which is given in the question. We have a curve also, which is y equals x square plus 2x. So just write it here, y equals x square plus 2x. Just differentiate it. Dy by dt is going to be 2x plus 2 plus 2. But we are not going to stop here because we are differentiating with respect to t. So x square also and 2x also will give you dx by dt. So I am just taking it outside, dx by dt. At what points on the curve are the x and y coordinates of the particle changing at the same rate? The dx by dt are equal, which is given in the question. So 2x plus 2 is equal to 1. You can take 2 common, or you can bring 2 on the right hand side. So this is going to be negative 1 because 2 on left and right on 1 will give you negative 1. So x equal to minus half. Now what will be the value of y if x is negative half? It will be negative half whole square plus 2 into minus half is going to be negative 3 by 4. So x and y are what? negative half and negative 3 by 4. This is your x and y. At this point, the rate will be same. If y is equal to 7x minus x cube and x increases at the rate of 4 units per second, unit can be anything, okay? It can be centimeters per second, meter per second. How fast is the slope of the curve changing when x is equal to 2? So let us see how we are going to do it. We are going to just differentiate it. We are going to use the point which is given in the question. Let us do this. Y is equal to 7x minus x cube. We are interested in dy by dx. Slope is dy by dx. It is tan theta. It is slope. It is the anti-clockwise angle from the positive x-axis. So it is differentiated. Dy by dx we are doing. Please remember, dy by dx we are interested because it is talking about how fast is the slope of the curve changing. So dy by dx we are interested in. Differentiated 7, then x is 1, and then minus x cube will be 3x square. So this is your dy by dx. Now this is slope. Dy by dx is what? It is slope. So call it as slope. Now the rate of change of slope will be ds by dt. Now you have to do ds by dt here. So ds by dt, again we have to do this differentiation. Ds by dt is 7 is 0, negative 3 to the 6, 6x. So negative 6x it will be. And since we are doing it with respect to t, dx by dt will also be there. Dx by dt is already given, which is 4 units per second in this question. So dx by dt is 4 units per second. Unit can be anything, as I told you earlier. So minus 6, x is 2, because it is saying that how fast is the slope of the curve changing when x equals to 2. Just put this value, you'll get negative 48. And just write unit per second. You have to write this. You cannot just leave this. ds by dt is the rate of change of slope, m tan theta. A particle moves along the curve y equals to x cube. So this is the graph of y equals to x cube. We already discussed about that, but it is not being used here. Find the points on the curve at which the y coordinate changes 3 times more rapidly than the x coordinate. Just differentiate it. Okay, multiple values will come. Y equals to x cube, and y is equal to x cube, differentiated dy by dt is equal to 3x square into dx by dt, because we are differentiating with respect to t. Now there is a scenario here. They are given a condition. This you know, y equals to x cube, differentiation you have already known. Find the points on the curve at which the y coordinate changes 3 times. So y, that is dy by dt, rate of change of y, 3 times. So this will be equal to 3 times the dx by dt. dy by dt is equal to 3 times dx by dt. This is 3 times. So this we are going to replace here. Okay, you can either replace dx by dt as 1 by 3 into dy by dt, or dy by dt as 3 dx by dt. So when you replace this you can just eliminate. 3x square is equal to 3. So 3x square minus 3 is equal to 0. So 3 equals 3x square. That's why it is there. 3x square minus 3 equals 0. So 3 into x square minus 1 equals to 0. X square minus 1 can be written as x minus 1 into x plus 1. X equals to 1 and x equals to minus 1. So x is equal to plus minus 1. So we have to find out the value of y at x equals to 1 and x equals to minus 1. So let us see this. Y equals to x cube, x equals to 1, y equal to 1. X equals to minus 1, y will be equal to minus 1, because minus 1 whole cube is negative 1 only. So for 1 it will come 1, for negative 1 it will come negative 1. So 1 1 and negative 1 1 are those points where these conditions will be followed or will hold true. You have to write like this, okay? Find the angle theta which increases twice as fast as its cosine. So cosine is cos theta. So just call it as x equals to cos theta. So this cos theta is nothing but x. Find an angle theta which increases twice as fast as its cosine. So d theta by dt we have to find out, and this is going to be equal to twice of dx by dt. How? Because cos theta is dx only. X is what? Cos theta. So d cos theta by dt is nothing but dx by dt. I hope you got the idea. So d theta by dt is twice dx by dt, and x we have assumed it to be cos theta. So now let us differentiate this. Dx by dt is equal to cos theta is minus sin theta, and this is d theta by dt. And relationship between dx by dt and d theta by dt and dx by dt is already known to us. In this we are going to replace twice of d cos theta by dt, which is dx by dt. Replace this. This gets cancelled. You have 1 equals to minus 2 sin theta. Sin theta is negative half. So sin theta is half when it is pi by 6, which is 30 degree. In order to get a negative, you just have to add a pi here. So pi plus pi by 6 is going to be 7 pi by 6. I hope you are recalling the things when we were dealing with trigonometric identities. When sin theta is half, it is pi by 6. When sin theta is negative half, you just have to add a plus. Okay, add sugar to coffee. Remember all the quadrants. So theta is going to be 7 pi by 6. And this is your answer. Find an angle theta whose rate of increase is twice the rate of decrease of its cosine. So decrease means you have to use the negative first of all. So x is equal to cos theta, like previous question we have done. Find the angle theta. So theta d theta by dt is equal to twice of dx by dt. X is what? Cos theta. But it is negative. Please remember, because it is the rate of decrease of its cosine. So d theta by dt is a negative of twice, negative because it is decreasing, and 2 because it is twice, and it is of dx by dt because x we have assumed to be cos theta. So this is the only catch here. Means the trick of this question is this particular expression. So x is cos theta only. So we have dx by dt is negative 2 dx by dt. X is cos theta. Dx by dt is equal to cos theta is minus sin theta. In place of dx by dt, remember to replace minus sin theta, and there will be d theta by dt also, because we are differentiating with respect to t, not respect to theta. So dx by dt is, I am replacing this now. D theta by dt is replaced by minus 2 dx by dt. Minus minus become plus. So dx by dt on both the sides. So 1 is equal to 2 sin theta. Sin theta is half. We have already done in a previous question. It is going to be pi by 6. Theta is pi by 6. For this, all the condition given in the question holds. The top of the ladder, 6 meters long, is resting against a vertical wall on a level pavement. When the ladder begins to slide outwards. So this is a wall, and this is the ladder. Now this ladder is changing its position. It is coming down from the vertical wall and going on the, say, opposite direction of the horizontal, say, floor. So we have already done this type of question. So this is the length of the ladder, which is already given in the question, and this is 6 meters. What about this? Let's take it as x, let's take this as y. And they are asking, the rate is given, they are asking the rate. That means one will be dx by dt, one will be dy by dt. So rate is 0.5 meter per second, and it is sliding away from the wall. So dx by dt is given as 0.5 meter per second. So we need to find out possibly the x, which is at certain, how far is the foot from the wall. So x has to be found out when it and the top are moving at the same rate. When dx by dt and dy by dt are both same, then we have to find out, but before that we have to find out dy by dt. So dx by dt is given, dy by dt, that is rate of the y is to be found out, rate of x is given, the rate of change of x, rate of change of y is to be computed. So let us use the Pythagoras theorem, x square plus y square is equal to 6 square. Let us differentiate it. 2x dx by dt plus 2y dy by dt is equal to, this is constant, so it will be 0. It will be 36, but after differentiation it will be 0. So divide everything by 2, you will get x dx by dt plus y dy by dt is equal to 0. So x dy by dt will be equal to negative y dy by dt. Now this x and y has a relationship now, and in the question it is already given dx by dt is equal to 0.5 meter per second. Because it is sliding away from the wall at the rate of 0.5 meter per second. And there are also certain things being given, that is the ladder is 4 meters from the wall. So the x, when it is 4, dx by dt is 0.5 meter per second, and this y, what will be the y? And there is dy by dt, which is to be computed. So we need a y also. Okay, if this is 4, this is 6, again we are applying the Pythagoras theorem. So 6 square is equal to x square plus y square. X square is 4 given here, so this will be 36 minus 16, under root of 20 is going to be 4 5s are 20, and 4 5s are 20, so you can take 2 outside, 2 under root. This is 2 root 5. So let us write 2 root 5 here, and dy by dt. So dy by dt is going to be 2 root 5 in the denominator. So if you multiply root 5, numerator, denominator, you will get, or you can keep it like that also, minus 1 by root 5 will come. And this is also in meter per second, because dx by dt was already in meter per second. So this is the first thing they have asked. The second thing is, when dx by dt and dy by dt are same, that is when the top and the bottom, they are moving at the same rate, then what will be the relationship? So we have x square plus y square equals to 36, we have already used. But in this case, when dx by dt and dy by dt is equal, x equal to minus y. So you can replace x as minus y or y as minus x. It's up to you. Because we are supposed to find out x, so replace x by or y by negative x. So x square plus x square will be 36. 2x square is 36, x square is going to be 18, x will be equal to under root of 18, and 18 is 2 9s are 18. So when you take the root, it will be 3 will come out, 3 root 2. So x will be 3 root 2 meter in this case. A balloon is in the form of right circular cones surmounted by a hemisphere. So this is the diagram. There is a balloon which is, you can call it as a hemisphere right now, and it is the form of a right circular cone. So the cone is in is the base, having a diameter equal to the height of the cone. So diameter, that is 2r, is equal to height of the cone. H is equal to 2r is our relationship. First thing which we need to know. So when H is 9 centimeter, how fast is the volume changing with respect to its total height? So let me show you and explain the diagram. This is the hemisphere, this is the radius. This whole is R, and R will be 2r will be diameter, and this h, small h, is equal to twice of r, which is diameter. What about capital H? Capital H is, assume it to be h plus r. This whole total height of this, say, shape is h plus r. So the height will be equal to h plus r, but h is already equal to 2r. When h is equal to 2r and capital H is equal to h plus r, you can replace h as 2r, you will get capital H as 3r. So you can differentiate it and you can have a relationship. So let us differentiate this, and dh by dt will be equal to thrice of dr by dt. Now height is already given as 9 centimeter. Alright, okay, the question is, certain things are already given, and h is equal to 2r, so you know that you can find out the value of other values also. What is the volume? Just add the volume of this, 1 by 3 pi r square h for the below part and 2 by 3 pi r cube for the upper part. Since h is equal to 2r, just replace this h by 2r. 1 by 3 pi r square h, in place of h I am replacing it by 2r. Here also 2 by 3 pi r cube, in place of h we have already replaced by 2r. So what do you get? So 3 pi r cube. So 2 by 3 pi r cube, 2 by 3 pi r cube is going to give you 4 by 3 pi r cube. So the volume of the whole shape is going to be 4 by 3 pi r. Now just differentiate it. dy by dt will be equal to 4 pi r cube will be 3r square, and then dr by dt, and there is a 3 in the denominator also, so 3 will get cancelled. But dr by dt is what? Dr by dt you can replace it by dh by dt, because how fast is the volume changing with respect to total height? So dv by d capital H we have to find out. So here in this case we have dr by dt is replaced by now dh by dt divided by 3. So what do we got? dh by dt is equal to 3 dr by dt. This already we have done, and we have just done dv by dt as what? 4 pi r square dr by dt. This already we have done. Now we need dv by dh, that is d capital V by d capital H. Not small h. I am writing small h, but it is d capital H, because h we have taken as a small height and capital H is the full height. Now you can cancel these two out, you will get 4 pi r cube by 3. Height is given already. This height is already given, but we have capital H as 3r. This is small h I am writing by mistake, but it is capital H. So 9 equals to 3r, r will be equal to 3. Now put it here, 4 pi 3 square divided by 3, and when you compute this, you are going to get this, and keep it in the with pi on. So it will be 12 pi centimeter cube by second. Water is running into an inverted cone at the rate of pi cubic meters per minute. So it's a volume by time. dv by dt is given. The height of the cone is 10 meters and the radius of its base is 5 meters. How fast the water level is rising when the water stands 7.5 meter below the base? So volume and height. So we have to find out certain thing, that is, what is the rate? How fast is the water level is rising? So dh by dt we have to find out. So this is the shape. See, first of all, we have the total height is given as 10 meter. Total height is 10 meter. Radius of the base is 5 meter. So just write it as 5 meter. Radius of base is 5 meter. R is 5 meter. How fast the water level is rising when the water stands at 7.5? So total is 10. The upper height is 7.5. What will be the below height? That means up to the height where the water is being filled up. So 10 minus 7.5 is 2.5. So you have volume as 1 by 3 pi r square h, and we need to find out dh by dt. That I already told you. So water level is rising. So from it is right now 2.5. It will go, and dh by dt is to be computed. So h is equal to 2. It is already given. So dv by dt, what will be this case? See, this whole. When we compute this dv by dt, it will be 1 by 3 pi r square h. So you can just write it as h by 2 and you can square it. And then we have 2 by 3 pi, because this comes after the differentiation. dv by dt you have to differentiate. Volume is 1 by 3 pi r square h. You have to differentiate it. I hope you will be able to differentiate it, because one time you have to take r, one time you have to take h. And this h equals to 2r has only come after taking the relationship between h and r. So h by r is 10 by 5, that is, it is r is h by 2. That is why we are able to write this r as h by 2. So now this is already being done. So we have replaced h by 2, r as h by 2, and since h is twice of r, you can have dh by dt as twice of dr by dt. Now you can replace this. Okay, so you can take this pi by 3 outside. dh by dt also you can take outside. So you have h square by 4 plus h square by 2 inside. So you have 1 by 2 plus 1 by 4. So you have this 1 by 2, you can take common, and you have 2 plus 1 by 2. So you have 2. So this is 3 by 4. So finally what we got? Pi h square by 4 dh by dt. This is dv by dt. Volume was 1 by 3 pi r square. You differentiated it when we use the similar triangle, that is h by r is 10 by 5, that is h is 2r, and volume also we differentiate. Okay, dv by dt we have already found out. We are interested in dh by dt. Now dv by dt is already given, as I told you earlier. Water is running into an inverted cone at the rate of pi cubic meter per minute. dv by dt, just place pi. Then you can just bring down things so that they get cancelled out, and finally you can find out dh by dt. So this is 4 by h square, and at what height you have to find out? 2.5. It is already given in the question. So this dh by dt will be 4 divided by 2.5 whole square, that is going to be 0.64 meter per minute. Let me write it here, is 0.64 meter per minute. So this is your answer. Okay, 1 by 3 pi r square h and the similar triangles. A man 2 meter high walks at a uniform speed of 6 km per hour away from the lamppost 6 meter high. Find the rate at which the length of his shadow increases. So this question we have already done. So I'll just give you a hint, because 2-3 questions we have already done. This is 6, lamppost, a person is standing, he is 2 meter, assume this to be x, this to be y, and we will use this uniform speed 6 km per hour as dx by dt, because x is where he is walking, and we'll use the similar triangle. The dx by dt is already given in the question, as I just told you, it is 6 km an hour. By the similar triangle, the corresponding sides can have an equal ratio. 6 by 2 is equal to x plus y by this y. So 2 is a 6, 3y is equal to x plus y, and x is going to 2y. Now differentiate dx by dt is equal to twice of dy by dt. As I told you, dx by dt is already with us. It is here 6. This goes down. 2 3 is a 6. dy by dt is 3 km an hour. This is your answer. So I just quickly followed it because we have already done question like this. Surface area of spherical bubble is increasing at the rate of 2 cm square per second. When the radius of the bubble is 6 cm, at what rate is the volume of the bubble increasing? So we have volume, we have surface area. Just assume that you know about this. Surface area is 4 pi r square. Volume is 4 by 3 pi r cube. And this surface area and volume needs to be known to you. So surface area is 4 pi r square. Just differentiate it. ds by dt is 4 pi r square will be 2r dr by dt. So it will be 8 pi r dr by dt. So we'll get dr by dt from here, because this ds by dt surface area rate is already given, which is given in the question. It is twice, or not twice, sorry. It's 2 centimeters square per second. So 1 by 8 pi r, and this radius is already given 6, and ds by dt is already known to us. This 2 is already known to us. So you can just have it as, because this is the rate of change of surface area. Now you have 2 divided by 8 pi 6. When you solve it, you'll get 1 by 24 pi centimeter per second. This is dr by dt. Now the second part is volume. Volume is 4 by 3 pi r. Now what is the rate of volume of the bubble increasing? So volume is dv by dt. It's 4 by 3 pi 3 r square, and then dr by dt, and again dr by dt is known to us, radius is also known to us. So just dr by dt is just computed 1 by 24 pi, and at 6 centimeter radius is already given, 6 into 6. So you have this you can cancel, 6 4 is 24, 4 gets cancelled, you are left only with 6 centimeter cube per second. This is dv by dt, rate of change of volume. Right? This question will be taken in the next discussion. Till then, thank you so much. Take care of yourself. The radius of a cylinder is increasing at the rate of 2 centimeter per second. So we are talking about a cylinder whose volume is pi r square h, and its altitude is decreasing at the rate of 3 centimeter per second. So find the rate of change of volume. So we are talking about dv by dt. When the radius is 3 centimeter and the altitude is 5 centimeter. This altitude is 5 centimeter, radius is 3 centimeter. So it is increasing, radius is increasing. Increasing, we always use a plus. So we have dr by dt, which is given as 2 centimeter per second. And altitude is decreasing. So whenever it is increasing, we always use the positive sign. Whenever it is decreasing, we always use a negative sign. So it is 3 centimeter per second. I'm going to put a negative here just now. So you just have to differentiate the volume, dv by dt, radius is given, altitude is given, dr by dt is given, dh by dt is given. So this is for your reference, but we are going to solve it. Pi r square h is the volume, and we are going to differentiate this. dv by dt is equal to, pi you can take common. So r square, differentiation of this h is dh by dt. we are applying the product rule here. It is dH by dt plus h. We have r square is 2r dr by dt. Now, as I said, the increasing is plus, the decreasing will always be negative. So you have to put a negative in front of 3. dV by dt is this one. So we have a r inside, so you can just take r common. So you will have pi into r is radius is 3 in this case, and then this r into dH by dt, 3 into pi, then we have 3 into dH by dt, which is minus 3. Now we have this 5, h is 5 into dr by dt is 2. So this is 33 pi centimeter cube per second. This is the answer which is going to come. The volume of a metal in a hollow sphere is constant. Hollow sphere means what? That a ball, with a quite a thickness. So we will have two radiuses here, the inner radius and the outer radius. So volume of a metal in a hollow sphere is constant if the inner radius is increasing at a rate of 1 centimeter per second. Volume is what? Of a hollow sphere? It is the outer volume subtracted by the inner volume, and the volume is 4 by 3 pi r cube. If you take the capital R and small r, capital R for the larger radius and r for the inner radius. So volume is 4 by 3 pi r capital R cube minus 3 this r cube. So d small r by dt, the inner radius is increasing at the rate of this. So dr by dt is minus is increasing. So when it is increasing, we are not going to use negative. I'll just change it. See, always increasing is plus, decreasing is negative. So the radiuses are given, the small r and capital R. The bigger one will be capital R, smaller will be the 4. Find the rate of increase of outer radius. So dr by dt is to be found out. Now you will be able to do it. We already have a volume relationship. You just have to differentiate it. So dV by dt you have to compute, and we already know it is 4 by 3 pi. We can take it outside. R cube, differentiation of r cube will be 3r square d capital R by dt minus this small r cube will be 3r square, and then dr by dt, small dr are here. Now dr by dt is to be computed, that is the higher radius. Volume of a metal is constant. So when you do dV by dt, volume is constant, it will be some value. When you differentiate a constant value, what do you get? It is always 0. So on the left you are going to get 0, 4 pi by 3 doesn't count. The inside bracket will count, so you can take one on the left hand side, other on the right hand side. So 3r squared dr by dt is equal to 3r square dr by dt. So this dr by dt is going to be r square by capital R square, means small r square by capital R square, into dr by dt. So it is 4 square divided by 8 square. Dr by dt is 1. As I said, it is increasing. So the negatives will not count. Always decreasing will be using the negative. Increasing will always be positive. So when you compute this, you will get 1 by 4 centimeter per second, and this is going to be a d capital R by dt. So you just need to know the volume of the hollow sphere, which is 4 by 3 pi capital R cube minus small r cube, and that's how this is the actual thing. If you know this, other things are just the customary routine things which you have been doing since we started understanding the differentiation. So the answer here is 1 by 4 centimeter per second. One more thing I would like to highlight: negative for decreasing, positive for increasing. Any rate. Sand is being poured onto a conical pile at the constant rate of this 50 centimeter cube per minute, such that the height of the cone is always 1/2 of the radius of its base. How fast is the height of the pile increasing when the sand is 5 centimeter deep? Okay, first of all you need to know the volume of a cone. So this is how it is being formed. When you drop the sand, even if you drop it anywhere, you'll see it will form a cone, because there will be a base and there will be a top. That is, the recent sand will settle on the top. Now there are certain things which are given, that is height is radius by 2, that is the height is always half of the radius of its cone. 50 centimeter cube per minute is your dV by dt, because it is rate of change of volume, dV by dt. So you write 50 centimeter cube per minute, and the relationship between h and r is already known to us. H is r by 2, and we are going to use it because we are interested in finding out how fast is the height of the pile increasing when the sand is 5 centimeter deep. So we need dH by dt, so we need to eliminate the r in the volume, and when we eliminate the r, we have to put r as 2h. volume is 1 by 3 pi r square h, and dh by dt has to be computed like this. dh by dt. First r is 2h, so in place of r square just put 2h whole square, h will be already there, and this is volume. So you'll get 2h square is 4h square, so 4 by 3 pi h cube, h square into h is h cube. dv by dt we have to compute. So when you differentiate this and put this dh by dt on one side and other things on right hand side, because height is already known to us, which is 5. Radius we don't need because we already know the relationship between radius and height. So you will have to put in place of dv by dt 50, 4 pi will already be there, and in place of h just 5 square. So this is dh by dt. This is going to be 1 by 2 pi centimeter per minute. This is your result. A kite is 120 meter high and 130 meter of string is out. If the kite is moving away horizontally at the rate of 52 meter per second, find the rate at which the string is being paid out. So you are actually flying a kite, and the kite above the ground is 120 meter high, and the string length, that is it will be at some angle from the ground, and it is at 130 meter string out. Now this kite is moving away horizontally at the rate of 52 meter per second. Find the rate at which the string is being paid out. So rate at which the string is being paid out, let us say that you are standing here, and then the kite is above the ground 120 meter, and this kite is moving horizontally in this direction, which I just showed you by the arrow. So 120 meter is this one, kite is moving in this direction. X, let us say the rate of going at horizontal direction is this one, and this y is the rate at which the string is being say released. The thing which the question is said is being paid out, which is actually equal to the rate at which the string is released. So let us use the Pythagoras theorem. X square plus this y square is equal to x square plus 120 square. And let us differentiate this. 2x dx by dt is 120 will be 0, 2y dy by dt. Now you can just cancel this 2, and there is a relationship between x, y, dx by dt and dy by dt. So we need to find out dy by dt, as I suggested, the rate at which the string is being paid out. So dy by dt is x by y divided by dx by dt. So x, there are certain values which are known to us. Alright. So we need one more value here. That is, y is 130 here. It is already given. 130 meter string is out. Dx by dt, which is the rate, is also given 52 meter per second. X is to be known first. So 120, this is 130. So in order to get this x, it will be, we'll use the Pythagoras theorem again. So all the things which are known, I have just put it up, and next thing will be x square plus 120 whole square is equal to 130 whole square. So we get 130 whole square minus 120 whole square under root is as x square. X will be equal to, this is going to be directly, I am writing it is 50. This is the final value. So this is 20 meter per second will be the final answer. This is dy by dt. A particle moves along the curve, and this curve is y equals 2 by 3 x cube plus 1. Find the points on the curve at which the y coordinate is changing twice as fast as the x coordinate. So dy by dt is actually equal to twice of dx by dt. This is the question asking. Dy by dt is equal to twice of dx by dt. Now we have y is equal to 2 by 3 x cube plus 1. This the particle is moving along this curve. Now we need to differentiate both the sides. So dy by dt will be equal to, this is 2 by 3, x cube will be 3x square followed by dx by dt, and differentiation of 1 will be 0. So there is a relationship here, but there is one more relationship I told you in the beginning. dy by dt is twice of dx by dt, and we are interested in, I am replacing dy by dt as dx by dt, twice of dx by dt. So this gets cancelled, this also gets cancelled. dy by dt also means dx by dt we have replaced for dy by dt, twice of this. So x square minus 1 is equal to 0. This will be x minus 1 into x plus 1 equals to 0. So x will be 1 and x will be minus 1. Now what will be the value of y corresponding? For x equals to 1, y will be equal to 2 by 3 1 cube plus 1. Here y will be equal to 2 by 3 negative 1 whole cube plus 1. So 2 by 3 plus 1 and minus 2 by 3 plus 1. So 1 plus 2 by 3 is 5 by 3. 1 minus 2 by 3 is 3 minus 2 by 3, 1 by 3. So 1 comma 5 by 3 is first, minus 1 comma 1 by 3 is the second point. Find the point on the curve y square equals 8x for which the abscissa is x, ordinate is y. for which the abscissa and ordinate change at the same rate. So dx by dt is equal to d by dt is given in the question. So the curve we have to differentiate. Y square equals to 8x. So this is y square equals to 8x. Just differentiate both the side. 2y by 2y dy by dt is equal to 8 dx by dt. So dx by dt is dy by dt. They both are equal. So 2y dx by dt equals to 8 dx by dt. You can cancel these two out. Y is directly equal to 4 here, and since x is y square by 8, you can find out x from here. That is y is 4, so 4 is 16 by 8. It will be 2. So for x 2, y is 4, so 2 comma 4 is the point where abscissa and ordinate change at the same rate. The volume of a cube is increasing at the rate of 9 cm cube per second. dV by dt is given as 9 cm cube per second. How fast is the surface area increasing when the length of an edge is 10 cm? So surface area is ds by dt. Increasing when the length of an edge is 10 cm. So x is equal to 10 cm. So volume of a cube, we already seen that if there is a cube edge or side we take it as x, volume will be equal to x cube. Surface area of a cube is 6 into side square. So volume equals to x cube. dv by dt will be equal to 3x square dx by dt, and this dv by dt we already know it's 9. X is 10, put it here. 3 into 10 square. dx by dt can be computed from here. This is a 9 divided by 100. This 3 divided by 100 is 0.03 centimeter per second. This is your dx by dt. Now how fast is this surface area increasing? So we are interested in ds by dt. Surface area, as I just suggested, surface area of a cube is 6 into the side square. So 6 into side square is surface areas. So you can just write this, and then you can differentiate this. ds by dt is equal to 6. X square will be 2x dx by dt. So 6 into 2 into x is what? You have x as 10. And dx by dt we have just computed. It is 0.03 centimeter per second. When you compute this is going to be 3.6 centimeters square per second. ds by dt, that is the rate of change of surface area, is 3.6 centimeters square per second. So dx by dt computed and then placed in the ds by dt. The volume of a spherical balloon is increasing at the rate of 25 centimeter cube per second. So dV by dt is given as 25 centimeter cube per second. Find the rate of change of its surface area at the instance when radius is 5 centimeter. So radius is 5 centimeter, ds by dt has to be found out. So we have already done question like this. So volume is 4 by 3 pi r cube. Surface area is 4 pi r square. So volume is 4 by 3 pi r cube. dV by dt will be equal to 4 by 3 pi 3 r square dr by dt. And r we already know, 4 by 3 into pi into 3 into pi square. dr by dt can be computed from here because dV by dt initially I told you it is 25. So when you solve it, you are going to get dr by dt as 1 by 4 pi centimeter per second. Now rate of change of its surface area. Surface area is what? 4 pi r square. ds by dt is equal to 4 pi 2r dr by dt. That is going to be 8 pi r dr by dt. This r is 5. dr by dt we have just computed as 1 by 4 pi centimeter per second. So this ds by dt will come to 10 centimeters square per second. The length x of a rectangle is decreasing. X is the length, is decreasing at the rate of 5 centimeter per minute. So length is dx by dt. So this is decreasing. So it has to be negative 5 centimeter per minute. And the width y is increasing at the rate of 4 centimeter per minute. So dx by dt was negative 5. dy by dt, because it is increasing, we have to put it in the positive. It is equal to 4. So when x is equal to 8, y will be equal to 6. Find the rate of change of the parameter. Just see when this x8 and y6 will be utilized. You'll see here. So this is the rectangle. The opposite sides of a rectangle they are equal, and the perimeter is simply twice of x plus y, because if a length is x, width is y, twice of x plus twice of y, which is the perimeter. So dp by dt is 2 dx by dt plus dy by dt. So you don't have to do anything. Dx by dt is with you, dy by dt is also with you. Just put it here and answer will be there. Now, as I said, what about x equals to 8 and y is equal to 6? So this will not be used. This is just redundant, just to confuse you. Okay, so there is no use of this 8 and 6 in this question. Just put -5 and 4 in place of dx by dt and dy by dt, and just compute. This is going to be -22 centimeter per minute. This is your answer. Now, this is your x, this is your y, and this is how it's to be computed. Again, the same question. See, these questions are exactly similar, but now we are talking not about the perimeter, we are talking about the area. So this dy by dt is 4 in this case, which is positive we are going to take. Dx by dt, since it is decreasing, that is decreasing at the rate of 5 centimeter per minute, dx by dt is -5 centimeter per minute. X is given as 8, y is given as 6 centimeter. Now we are interested in area. Area is what? Length into breadth, or length into width. So it will be x into y. dA by dt will be x, dy by dt plus y dx by dt. Now we are going to use this 8 and 6 in this question. So x is 8, dy by dt, y is 6. So these both value we know. Dx by dt is -5, dy by dt is +4, and when we compute this, it's going to be, for the 32 minus 30, that is going to be 2 centimeters square per minute. So this is dA by dt. Okay, here 8 and 6 is utilized. In previous question it was not being utilized. A circular disc of radius 3 centimeter is being heated. Due to expansion, its radius increasing at the rate of 0.05 centimeter per second. So radius is 3 centimeter. dr by dt is increasing, so it will be positive 0.05 centimeter per second. Find the rate at which its area is increasing. So dA by dt is what we have to find out when the radius is 3.2 centimeter. dA by dt will be pi. This is 2r dr by dt. So 2 pi r dr by dt. When the radius is 3.2 centimeter, let's see. So this is 0.32 pi centimeter square per second, because it is going to come. All the things are given. That's why those who want to do by themselves, the answer will be 0.32 pi centimeter square per second, because r is 3.2, dr by dt is 0.005 centimeter per second. This is your final answer. So this is all about this exercise. Thank you so much and take care of yourself.